everyone, we're going to identify and graph the polar equation r equals 4 sine of 5 theta. This is going to be a rose with 5 petals, and we're going to check for symmetry to graph this because it'll make it easier for our graphs if we can just graph with knowing our symmetry. The first symmetry that we want to check is with respect to the polar axis. So what we're going to do is substitute this theta with negative theta and see if we get an equivalent equation. This gives us 4 sine of negative 5 theta. Since sine is an odd function, this negative can be put up front here. Since these aren't equivalent equations, it means this test fails and our graph will not be symmetric to the polar axis, i.e. the x-axis. So let's check for the second test. The second test, we're going to check to see if it's symmetric with respect to the line theta equals pi divided by 2, which is the y-axis. And we're going to substitute in our theta for pi minus theta. So you can get r equals 4 sine of 5 times pi minus theta. All right, this equals 4 sine of 5 pi minus 5 theta. All right, so we're going to substitute this in for our difference formulas for sine and expand. So we're going to get, this is going to be equal 4 times sine of 5 pi times cosine of 5 theta minus cosine of 5 pi times sine of 5 theta. All right. Let's do it that way. Now, sine of 5 pi is 0, so all this is going to equal 0. Cosine of 5 pi is negative 1. So you have two negatives. This is going to be a positive. So we're going to get 4 sine of 5 theta. Since we have an equivalent equations here, this test passes. So our graph is going to be symmetric to the y-axis. For our pole, the origin, we just replace our r with negative r. And very clearly it does not equal the original equation, so this test fails. Since we have, this is the only test that passes, this tells us that we're going to assign our values for theta between negative pi divided by 2 and pi divided by 2 and use the fact that it's symmetric to the line theta equals pi divided by 2 to help us graph. All right, so I went ahead and assigned the values here and we have to fill this in. And this is what we're going to be symmetric to this line right here. All right, so let's fill in some of this. We're going to get negative 4 here. 2 square root of 3, that's approximately 3.5. 2 square root of 2, that's approximately 2.8. Negative 2, 0, 2, and then negative 2 square root of 2, that's approximately negative 2.8. Negative 2 square root of 3, that's approximately negative 3.5, and then we have 4. So let's start from the very beginning at negative 4. So at negative pi divided by 2, that's here, we're going to -4. So we're going up 1, 2, 3, 4. There's that point. I'll make it really big here. Now at negative pi divided by 3, this is this one, we're at 3.5. So you go out 3, 1, 2, 3.5 is right there. All right, and then at negative pi divided by 4, that's about here. We're at 2.8. That's close to 3. And then at negative pi divided by 6, we're at -2. That's there. And at 0, we're at 0. So let's see what we have so far. We have it coming down, or well, let's fill out some more. At pi divided by 6, we're at 2. At pi divided by 4, which is right here, we're at -2.8. So we're going down this way. 1, 2, 3. All right, and then at pi divided by 3, we're at -3.5. So right about there. You can kind of see the symmetry here. We have 2 dots here, 2 dots here, 2 dots here. And then at pi divided by 2, we're at 4. So it ends here. So let's see. We're going from this one is our starting point. And then we're going to negative pi divided by 3. And then the next one's here. So we're going like this. It's kind of coming around like this. Comes back up around. It comes back through. It comes back around. Comes back through this. Comes back around. We could have actually used more points. Comes back around. This one's probably better used with a calculator, huh? All right, so that's kind of the sketch of the graph. Make this a little more curvy in here. It looks kind of nice. Thank you. Have a nice day. Bye-bye.